Hello, my name is Christina Ruiz, and I work in the Cost Benefit Analysis Division. I've been working at TRAC just about 11 years. I've actually worked in two different areas here in TRAC. So when I started, I was a scenario integrator for Combat 21. That's from one of the previous presentations you've probably heard. And for the last 7 years, I've been working in the cost division. So I have a bachelor's and a master's in industrial engineering. I was about halfway through my master's when I started working at TRAC. And with one of the opportunities here at TRAC, I was able to go to ORSAMAC, and that actually finished the other half of my master's program, and I was able to graduate a lot sooner than I had thought. So there definitely is a lot of opportunities here at TRAC for furthering your education. I also live here in Las Cruces, so I'm a local. I went to college here, and honestly, I grew up about 3 hours from here. So I love the area, and I'm a local through and through. So for today, I'm going to go over kind of the different, not only what cost does, but how we impact the studies here, and then go over an example. So next slide, Sarah, please. So cost benefit analysis is a critical part of all TRAC studies. Our studies are able to inform Army senior leader investment decisions. And by Army senior leader, what I mean is the Secretary of Defense, Secretary of the Army, Chief of Staff, or a 3- or 4-star general. So we're helping them inform these investment decisions. So these investment decisions help soldiers and unit mission capabilities to fight and win in the future. We're looking at what to buy and what's going to help them for their future missions. Our studies compare costs and operational benefits for multiple alternatives. And I'll go over alternatives and some examples on the next slide. So the cost benefit analysis division, there's different types of cost we do. And that really depends on our timeline and what exactly we're looking at. One of the different costs we can do is a ROM estimate. Like I said, where a lot of the stuff we look at is future. So we don't know what something's going to cost in the future, but we can estimate it. And I'll go over some of the examples later in this presentation of that as well. We also look at different cost confidence levels and risk distributions. Those are just ways for us to add a little bit of risk into the different components of a cost. If we know that there's a particular technology that's going to be an issue down the line, then we can add some risk to that to increase the cost of that one component, knowing that there's going to be some issues down the line that could cause the cost to go up. And really, that just stems from the cost confidence and risk of new technologies, because we just don't know, right? Where we're using historical data and different types of input for that, which I'll go over later in this brief. Sarah, could I go to the next slide? So for this slide, I kind of wanted to go over alternatives and some of the different types of studies that COST has worked on. We're conducting cost analysis for current operations, but it's basically what we have now and then how we can use it in the future. Some of the things we can look at are a current system that we have, so modifying that existing system or getting a brand new system, or maybe just different technologies on top of the old one, maybe a different engine. So there's lots of different ways we can look at those different alternatives. Typically, it takes us about 9 months to do a study. I mean, some of them can be a little bit shorter. There have been studies that have been about a year long, but the good part about working on these different studies is as soon as it's over, you get to jump on another study. So there's always opportunities to learn. You might be working on a vehicle study for 9 months, and then your next study is going to be, an aircraft. So it's always kind of the jump. I personally really like the jump and the focus on something completely new, or even if you look at something similar, it's going to be you're looking at different technologies. So you're always going to be learning different things. Some of the examples I have here are some of the different cost studies that we've done recently. So ones that we're working on now are ones that we've just completed. So on the top one, it's the optionally manned fighting vehicle. That's just a new infantry fighting vehicle. Some of the technologies on there, some of the weapons are changing. Some of them are bigger, smaller, can go further. Some of the vehicles are going to be all robotic, or there's a potential for them to be all robotic versus soldier driven. So there's a lot of different cost components that will be looked at in that, or were looked at, and then now will be looked at in the future for the next iteration of that study. The next study is the Future Attack Reconnaissance Aircraft. That's just a new Army helicopter. Technology changes all the time, so we have to meet with that technology. So there's new types of things that can be incorporated to make it more survivable during different missions. Another study would be the Extended Range Cannon Artillery. This basically is, once again, with the technology. We have to adapt to the new technology in order to exceed the capabilities that we currently have now, always looking for bettering ourselves as an Army. And then the last study I kind of wanted to touch on was the Army Tactical Telemedicine Study. This basically just helps Army medics and doctors transfer medical data from multiple patients as they're transported from where they're injured to where they're going to receive care. So it's just, if a lot of different injuries come in at the same time, it's how do we get all of that data and it follows that person so that they can receive the right care. So now that I've gone over some of the different studies, my next slide will go over, how we've worked on this and how we do it. Next slide, Sarah. Okay, thank you. So for this is our cost analysis process. First, I'm going to go over the planning box, which is the tan, and then after that, I'll go over the green, which is how we execute our cost studies. So we don't work in a vacuum in cost by any means. We rely on a lot of different agencies and different people to be able to get the data we need. An example of that would be, in our building the team, the program managers are the ones who interface with industry and actually get things built. The S&T community is one of the largest employers of engineers, and we talk to them frequently, and there's different S&T across the Army. The user community understands what the soldier wants and what the soldier actually needs, right? So, there's lots of different validated agencies and different people we talk to, but, one of the more fun parts about my job is I get to talk to people from all over. Like I said, we don't work in a vacuum. We have to talk to a lot of different people to get all the right people in the room to talk about different technologies and the costs of either upgrading it or keeping it for as long as we need it, or trying to modify it to our needs. The next step would be to identify the cost factors. So there's different quantities we can look at. So how much we're going to buy, when we're going to buy them, and then especially we need to look at a budget. So we don't have an infinite amount of money, so we always need to be able to look at a budget. And one of the fun parts about our job is if we don't meet the budget, there's different things and different ways we can buy things so that we stay under the budget. Or, honestly, if it doesn't come under budget, that's something that we need to call attention to as well. So we look at not only the system, but how much it is to prototype it. And as it matures, of course, you're going to get better and better information. So something that maybe is just a engineering sketch right now is not going to have the same data as something that's already prototyped and built. So we need a way to compare all of those different maturity of technologies together. And that's what we do in cost. We find a way to be able to compare those different technologies across the board. So for the scope and analysis, that's where we're able to pull out that different type of information. If it's a program that already exists, if it's a technology that already exists, we look at the R&D, the testing, prototyping, and all of that. But also if it's not something that exists, that's where that building a team is so important, because we can talk to the engineers or program managers and ask them, hey, what do you think it's going to be to prototype this? What issues do you see down the line that could be a big impact to cost? And a lot of the times they can tell you and pinpoint, it's this technology. We're relying on this to be further along by the time we start building it. And if it's not, that's going to really impact our cost. So those are all things that we look into. We also look into, the people who are actually working on it and the construction that's needed. So if you need a certain type of building or storage, those are all different parts of the cost we have to look into. So for the analysis portion, there's different types of cost analysis we can do, and this just goes back to the information that we have, right? So we can look at something that's similar to what we're looking at for cost. We can look at historical data, say we want to use some program that was used maybe 20 years ago, but we're just going to modify it, then we have to look at those historical costs and see what they were and inflate them to bring them to where we're at now in order to start adding the different technologies on there. And for some of these technologies that are not as mature, we do talk to a lot of subject matter experts. Once again, talking and reaching out to program managers, seeing if they can talk with industry, talking with people who are actually building it or trying to build it. And a lot of that will come in with some of the technologies that are just not as mature as others. We also look at the schedule and cost risk. I kind of touched on it a little earlier in this presentation. It's basically if we know there's a certain technology, but it's reliant on something else, which a lot of times there are technologies that rely on other stuff for integration or whatever may be the case. This is an opportunity to kind of let decision makers know that we need to add some risk onto these particular components, or to bring that out to decision makers and let them know that, this entire vehicle is dependent on this engine and this working correctly and this being built, or the modifications for it being built by a certain time frame. And those are all good things to bring out to decision makers to help them decide what they want to buy. And of course, affordability, that goes back to, can we afford this, and the differences between the different alternatives. And I'll go over some of that in my next slide when I go over an example to kind of get kind of all these terms that I've talked about together. The next step would be the synthesizing the study results. Really what I wanted to mention on this point was that, all the data in the world is great, but if you can't present it and articulate the importance of the different parts or the different costing to your decision makers, then data is just data. So it's very important too to be able to put a presentation together, or to be able to brief a senior leader and let them know, hey, this is how much it costs, but here are your problem areas. And, that's one of the tougher part, I think, about being an analyst is, my favorite part is digging in the numbers, but definitely it's very important to be able to show other people what you've been working on and what you were able to find out through the duration of the study. Can I please go to the next slide? So on this as well, it talks about trades and excursions, and that's I'm going to hit home on this final slide about an example of a life cycle cost. So I kind of hinted before that we look at the different parts and the different types of cost, but I really wanted to more talk about it in this slide. So as a cost analyst, we look at the life cycle cost of something. So we look at not only how much it is to the research and development to build something, but we also look at how much it is to buy it, how much it is to maintain it, and then how much it is to dispose of it. So I thought it'd all make more sense if I used an example that might be a little bit closer to home for everybody. So the example I'm going to use is buying a new car. So when you're buying a new car, you're paying, if you buy a brand new car, you're paying for them to start the line to build that car. You're paying for all the engineers and all the different people that put that car together. And that's where the cost comes from for that, right? But when you buy a car, you don't just buy a car. You think about how many people do I need to fit into this car? You think about, how much fuel mileage you need. A family of 2 is going to need something far different than a family of 7 or more. You think about the fuel economy versus the cost versus the reliability. Maybe you don't want a new car. Maybe you want a used car. With a used car, you have to watch out too, because you save money, but you're kind of stuck on the top of that. So you save money because you're not paying for that research and development, right? Because somebody's already owned it. It's an older car. But you're kind of stuck in the middle of that O&M cost on the top of the curve, because since it's an older car, chances are you're going to have to replace the tires. You're going to have to do a lot more maintenance on it. So whereas for a new car, you probably wouldn't have to do a lot of maintenance on it. So these are all things that you would want to look at if you were buying a brand new car. You have to be able to account for all those costs. So even if you plan to fix it yourself, you think that's a cost savings. When the Army, we really can't look at it that way. You know, you don't really save money by fixing it yourself because you're still paying for the mechanics to be able to fix it for you, or you have to have a group of mechanics on hand or the equipment. So really, you have to look at all the different facets of it, right? So as the Army, we have to look at, you know, if we're buying something new, we have to look at this is how much it's going to be to build this thing or to start up a manufacturing line to build the vehicle. And then next you look at, okay, this is how much it is going to be now to buy all the parts and to get all the people to work on this. And this is how much the cost is going to be. The next part is the O&M cost. So if I'm going to keep this vehicle for 25, maybe 30 plus years, you know, I need to look at how much is the maintenance going to be? How much is the fuel economy going to be? How much is it going to be for the program manager to maintain this and to sustain this for however many years I need to keep it going? If it's a vehicle, I need to buy tires every so often. So it's basically just the upkeep of whatever we had just purchased. And then the disposal cost is you know, there's not some dealership we can just go to drop all these vehicles off. So we have to think about disposal. So disposal of tires, disposal of the metal, or maybe we're scrapping it and taking parts to put into a new program. So I kind of said earlier in the slide I was going to talk about, or in my previous slide, I was going to talk about trades and excursions. So for an example of trades and excursions that kind of we look at, because that's what we look at in our studies for this example would be, you know, the trade of a pickup versus a dually four-wheel drive, you know, with all the bells and whistles. Maybe I don't need all the bells and whistles. Maybe I'm okay with a truck. And if I have a job I need to do that requires, you know, the four-wheel drive and something bigger, I can just rent one. And it would be cheaper to do that than to buy a vehicle at the beginning with all the bells and whistles. Something else too that even the Army looks at right now is maybe you don't want a gas car. Maybe you want an electric car. And the Army has looked into different ways that we could do that as well. You know, with the Army, we have to keep up with the times, just like I had mentioned before with technologies evolving. As an Army, we have to, you know, keep up with all of that as well. So maybe we don't need a gas-powered vehicle. Maybe we need an electric, and that's suitable. And maybe we only buy a couple of the other vehicles for certain types of missions. So those are all different things that we can look at. I mean, Army has looked at electric versus gas for the OMFV, so the optionally manned fighting vehicle that I spoke about earlier. That was one of the options, was maybe we should switch to electric versus the gas power, and that's one of the alternatives now that we're looking at. Electrics are different since they have a lower operating cost. So, you know, for cost, it's not just how much it is to buy something, but it's how much it is to make it, how much it is to produce that thing, how much it is to sustain it over its life, and how much it could be to dispose of it, whether we scrap it for something else or we have to get rid of the tires or the blades or whatever it is for that particular study. So that's my presentation for now. Does anybody have any questions? Okay, nothing heard. Thank you very much.
So I don't see any hand raised, Christina, but I can think of something as I was watching your presentation. Do you always know when you're working up your cost estimates what the budget for a particular program is going to be, or is that kind of a fuzzy gray area?
So the latter. Sometimes we have studies where they know exactly how much they can spend. And sometimes they give us the amount of money they can spend in 1 year. And when I had mentioned before in my presentation that there's ways kind of around that affordability, which is if I can only spend so much per year, then maybe I don't produce as many, right? That maybe that's one of the trades, is to not go over budget. I'm going to produce less vehicles in each year so that I can stay under budget. But sometimes they absolutely don't give us an affordability, and it's just they want to know how much everything costs. Sometimes it could be, okay, well, we have this much for 30 years. Don't go over it. So maybe we spend a little bit more at the very beginning making all the vehicles, and then it kind of evens out towards the end, but we're still under our affordability. So it just depends on the study, on what they give us. Usually there's always a way that you want to be able to show some type of cost savings, even if they don't give you a sure number, just so that they have some options on if they want to do some type of trade.
Okay, that makes great sense. The other thing I was curious, with your degree in industrial engineering, you've been a scenario integrator and you've been now in cost. So can you tie your degree back to what it is you're doing in your job today?
Sure. So as an industrial engineer, I always kind of wondered, I guess as a student, you always wonder, how am I going to use my degree? For cost analysis, actually, it helped out a lot. Back in school, we used to learn a lot about the different manufacturing lines and how to pull, the different product to that line, how many people it would take to work that line. And a lot of that has been able to be applied now. Now when I look at it, I look at it at a lens through of an industrial engineer. So when people are talking about the research and development portion and the procurement portion, I do look at it through that lens. I think about, how many people do we need to really work this? We also apply learning curves, which is a lot of what industrial engineering would be doing, right? Because you want to make sure that you want to get the best cost savings possible. So at the beginning, things are always going to be more expensive to start a line, but once everybody learns their job and everybody gets the rhythm, it gets cheaper. But at a certain point of that learning curve, it no longer gets cheaper. It's kind of steady state. And when we're looking at these models, there's a balance in there. And I'm able to use a lot of the statistics and tools from my school days, and I'll be able to apply those to figure out where that certain almost sweet spot is of, okay, we're now at a point where we're not learning anymore. This is the best we're going to get, and we need to apply that when we're procuring things. That's kind of when I'm moving around the production of how I'm buying things. I always need to keep that in mind, because if I spend too much time in between my procurement cycles, then everybody's kind of forgot. If you build something today, you get really good at it, you're comfortable, and I say, okay, we'll come back in 5 years and do it, then you're going to lose all that knowledge. So you always need to kind of keep that in mind with cost as well, because you don't want to spend too much money. You want to make sure everybody does their job well and efficiently and is able to produce things at the best and cheapest price for the Army.
Great, thank you. Do we have any more questions from the group?
I see a Braden's hands up.
Yes, hello.
Hi.
Yeah, my name is Braden Stoyer. I was just curious, how closely, or could you touch on how closely you work with more of the data analytics side of the gentleman that just did his presentation on for a lot of the things you need to analyze for, you were saying, technologies maybe not being fully developed by the time you're ready to produce the product, or how long it would take before the Army is ready to implement a certain product. Do you work with their analytics teams or have those kinds of people on your teams to help you with that kind of thing?
Absolutely. So when we do our cost estimations, like you said, sometimes these things don't exist. So what we use is cost estimating relationships. And basically that's looking at kind of those different distributions of where do we think the risk is going to be? How much do we think this is going to be? How much do we think this is going to cost? How similar is it to a previous program? What costs can we pull from that previous program? So, I mean, we work a lot with those different types of teams, and usually there's always some type of engineer, or sometimes we enlist people from here and TRAC and the other divisions to be able to help us with that type of information. So all of our cost estimates actually go to another agency, and they scrub them and look through them. And that's one of the things that they will look at. They will look at every single cost line that I have in my models, and they will want it documented. And a way I can document it is by using those regressions and cost estimating relationships to compare it to something that either we've previously had, or something that they project that we're going to be able to have.
Awesome, thank you.
Are there any other questions?
Hey, Christina, this is Rick. I'm going to put you on the spot a little bit, but can you talk a little bit about how you work with the schedule and risk guys out of DAC and what they provide and how you would coordinate with them in terms of schedule and how you might chart it, along with this, how you might do like cost benefit charts with the analysis team and how you bring that stuff together?
Sure. So earlier in the presentation, I said we don't work in a bubble. When I talk about schedule risk, I can give an example. So one of the studies that I'm working on, they're looking at a lot of different technologies. So some of these technologies are more mature than others. We rely on some of the outside agencies to kind of work with us on those technologies, and they're able to tell me, this technology is just a draft right now. It's just an engineering drawing, something they want to do. They can tell me if it's an existing program, or they can tell me, oh, you know what, there is a prototype out there. And of course, any industrial engineer in here will know that that prototype is probably the most expensive thing you'll ever see, because it's the first unit cost. So it's the first time they ever made something, and that's always going to be the most expensive. So ways we work with them are they'll tell me, hey, this is not available yet, but they are planning to prototype it within the next 2 years. So when I look at my cost models, that's how I reflect it in there, is that the cost is not going to start right now. The cost for prototyping it will start in about 2 years. So right now is probably the research and development phase of that. Because different technologies are going to be ready at different times. And sometimes with the Army, they'll tell us we're looking to field something by, the year 2026. Okay, well, as I'm going through, working with the schedule and risk folks, they're telling me, yes, that's possible. And I'm putting it in my model. And then we find out, hey, there's something that's not going to be prototyped until, way after that, or it's just the technology's not there yet. So that's something that's reflected in my cost. And when I spoke about cost risk earlier, that's something that I can put in my model as well to say, hey, maybe if you invest more money in this one particular area of this vehicle, we can get it built sooner, but it's a lot of cost. And there's a lot of risk because it still might not happen because there's some trouble with the integration. How we kind of bring that all together is we work pretty closely with the schedule people in the different agencies, just because if I'm reporting something out to say that it's all the costs are ready, this is how much it's going to be every year for the next 25 years, and they're telling me it's not going to be ready yet, we need to make sure all of our information is kind of cohesive across the different agencies. And how I tie that into the study team is I now have from the different agency, here's the schedule of how they anticipate all of that stuff's going to happen. Now I have it in my cost model, and I've moved it across several years to say, okay, this is how much you're going to spend in each of these years. And now I'm able to get the benefit, that everybody kind of wants to know what's the benefit of your money, right? So now I tie into the study team, and they're able to show maybe something's more survivable. So they'll say, okay, well, hey, we got from the cost and risk team, this vehicle is going to be ready on time, and it's going to be ready, by the time you need it fielded. But you know what? It doesn't have that good of weapons, and it's not very survivable. Well, that now you're showing the benefit. You're saying, yes, it's the one you can get off the line faster. It's the one you can get much quicker than anything else, but it probably is not the best one for you to buy. So it kind of gives the decision makers an ability to say, oh, I'm getting this one faster, but I'm not getting a good bang for my buck, versus if I wait 2 years for this other one, it's more survivable, it's better for the soldiers, it has more capability. And now you're showing the difference between this is the cost, this is the schedule for everything, and now here's the benefit from it. If I just wait maybe an extra year, or if I invest more money into this technology, it's worth it because it can be ready faster and it has better capability.
Does anybody else have a question?
All right, well, thank you very much. I
Thank
appreciate
you so much, Christina. That was an awesome presentation. We will meet back here in the main meeting room at 12:30 for the TRAC-WSMR IT presentation.